so we have negative 4x plus 10y equals negative 20. And you started it, right, David? Okay, so what's the first thing we're going to have to do in order to graph this? Put it in slope-intercept form. Now, we've done so many different graphing things. Did that come foggy to anyone? Like at first we were like, I'm not sure what to do, or you got it. Okay, if you weren't sure, then what you should do when you write this down in your notes, because I'm going to get this back to you so you can have it in your notes, tell yourself what to do. Put step 1, turn it to slope-intercept form. So let's go ahead and do that. Ready? We're going to add this to the other side, and then we're going to get rid of the 10. So we have y equals 4 divided by 10x, and and then minus 20 divided by 10 is 2. Anyone disagree or find error in what I did? Is that what you came up with as well? Okay, so then what we do, we can reduce this, right? We wouldn't have to, but we can reduce it to be 2 over 5, okay? It's 4 over 10, so we can reduce it to 2 over 5. That won't change anything because it's an equivalent fraction, and I'll show you that in a second. And the goal was to graph this. So what do we know based on this? Yep, we know that b, or our y-intercept, is negative 2, and we know that m, or our slope, is 2 over 5. And so b, we come down here to negative 2, and we go up 2 and over 5, 1, 2, 3, 4, 5-ish. And then we draw our line, and we could also, from here, we could go down 2 and over 5. Ooh, that was a pretty good line. I should drink Mr. Haas's coffee more often. All right, and then we're going to label it with this, which is negative 4x plus 10y equals negative 20. Okay, questions at all? Yes, sir. Trying to stay out of the way for the video thing, I'm sorry. Okay, so we started here, we turned it into y-intercept form, we identified slope, which is our m, and our y-intercept, which is negative 2. Based on these two numbers, we can graph it, and then we label it with standard form. The question now, could you do this tomorrow, or Monday, or whenever you're doing it?
How did you get
from 4 over 10 to 2 over 5?
you reduce that?
And you wouldn't have to. Let me show you why I wouldn't have to.
Where did the negative go?
Okay, right here. To get rid of this, we add 4x to this side, and we add 4x to this side. That's how we move this to that side over there. Inverse operation. Inverse of subtraction is addition.
Where did the
Yep. So let me write the steps out just since we have plenty of time. Ready? So when we get rid of this 4x, then we have 10y equals 4x minus 20, but we still haven't solved for y to get it into slope-intercept form. So we solve for y by getting rid of the 10, so we divide by 10 and divide by 10. Yes. Does that help? Because whatever you do to one side of the equation, you must do to the other side of the equation, so it means the whole side. So the steps that I wrote down as I was trying to think for you and the steps that you would want to write down, I wrote step 1 is to turn into slope-intercept form. Step 2, identify the slope and the y-intercept. Step 3, graph. And step 4, label.
You do one more so
Absolutely.
now that you showed us.
Absolutely. Someone pick a number under 10. Okay. So we have 3x plus or minus. Minus number 4y equals number over 10 but under 30. All right, 17. Okay, let's turn this, which is in standard form, into slope-intercept. So the first thing we're going to do is inverse operation. We're going to move this 3x. We move this 3x by subtracting it to the other side. We have negative 4y equals negative 3x plus 17. Questions? Okay, what's the next step we should do? The goal is to solve for y. So we could change the signs, or we could, when we move the sign, we could also move the 4. Okay? So we're going to divide both sides by negative 4. Divide this side by negative 4 and divide this side by negative 4. And what that looks like when we write it nicely, since that doesn't look very nice, we're going to get y equals a negative divided by a negative is a positive 3 over 4x. And then a positive divided by a negative, negative, good, negative 17 over 4. That's an improper fraction, so just so we can see it more nicely, we'll say how many times does 4 go into 17? And the answer is 4, remainder 1. So it's negative 4 and 1/4. Okay, and then how would we graph that? So the first step is this, turn it from standard to slope. The second step is to identify our slope. Joel, would you identify our slope? What's our slope?
Our slope is 3.
Over, yep, 3 over 4. And our y-intercept, David? Negative 4 and 1/4. Okay, so now we're going to graph it. Step 3. Good, because we had negative 17 over 4, and that's just messy to try to figure out where that is. So we take this improper fraction and turn it to a mixed number. Very good. Excellent. Okay, so then we have our graph. Based on this, what's the first thing we do? Y-intercept. Very good. Okay, so we come down 4 and 1/4, which we're going to just estimate is there. And we come down because it's negative. And then we're going to go where? Up 3 over 4. Very good. Up 3 and over 4. Or down 3 and over 4. Then we're going to draw our line. And we're going to label it, which is step 4. 3x minus 4y equals 17. Questions? Can you do it on Monday? I hope so too. Okay, question number 2. So if you'll mark the time on your paper, David, as soon as you get done.
I'm like, how many questions?
It's not completely finished right now, but it's definitely under 30 questions. But yes. But the bummer is that, you know, when you have a question, like one question is, you know, given these 2 points, graph this. So you're doing math. Given the 2 points, you have to, you know, determine what the whole slope and all of that kind of stuff is, and then you have to graph it. So even though it's like one question, you're doing more work than just worth one question. So it will be worth more points than 1 point. Okay, so let's talk about number 2. Thank you so very much. And I'm going to email you one more page in a little bit. That printer that I've had back there doesn't have a cord, so I can't do anything with it. So thank you very much. Will you mark that time? And this is for question number 2. Okay, for question number 2, all I want you to do, I want you to write down these page numbers. I want you to write down page 53 and write down the term undefined slope. We're going to look at it in just a minute, but I want you to write these things down first. The second thing I want you to write down is page 55. Forms of lines. And now I want you to write down examples. I want you to write down page 53, example 2, and example 3. Yes, sir. Page 53, example 2 and example 3. And page 55, example 5. Did you get that? Page 53, example 2 and example 3. Page 55, example 5. Okay. What I want you to do now that you've written those down, do you guys need a couple more seconds to write down stuff about the first thing we did? Okay, then open up your textbook and look at those pages and those examples, please. This reviews back to chapter 1, and the only reason I'm calling your attention to them is that it will be important for you to remember these concepts. So we start with page 53. I wanted to pull your attention to the term undefined slope. It's found underneath, it has the definition in red, you see that there? You go down 2 paragraphs, and it says, now consider the equation x equals 5. Since the x-coordinate must always be 5, the line passes through 5 at 0, 5 at 4, 5 at negative 3. The graph is simply a vertical line. Since m, slope, equals 0 minus 4 divided by 5 minus 5, that means that our slope is negative 4 divided by 0. The slope is, by definition, what word, gentlemen? Why? Explain to me why it's undefined. It has no slope, and therefore on a graph it would be a straight vertical line. So if you look at a graph and it has a straight vertical line, the slope is, by definition, 0, or but to answer better, undefined. And the reason we use the word undefined, I don't know if you remember this from last year with geometry, but anytime you have a number divided by 0, the proper term is not to say that it's 0, the proper term is undefined. Do you remember that from last year?
No, I just remember this part from the book.
Oh, Joel, quit thinking about your book.
No, it's like, guy asks one person to chaperone them, and he's like, this basically keeps us from doing anything inappropriate. He's like, unappropriate, like dividing by 0.
Oh, maybe I'll have to read the book. All right, no.
Yeah,
Oh, that's funny. All right. Well, that was the one term I want you to look at. The second one I want you to look at is turn to, oh, wait, actually on that same page. The one on page 53. Yes, it said example 3 on page 53, which the example 3 actually starts at the bottom of 52. Do you all see that example? Why would I call your attention to an example? Why? Yes, it looks very similar to something on the exam.
What number?
That's page 53, example 3. It actually starts at the bottom of 52. Okay, it says graph f of x equals 3x minus 2. Give the domain and range. Is it a function? Okay, you're given the slope, m. You're given the y-intercept, b. So now, could you graph that? Yeah, very similar to what we just did in number 1, correct? Okay, they give you the exact step-by-step directions of how to do that there on example 3, but I wanted to call your attention to it so that you saw that. Now, go ahead and turn over to page 55.
So, the undefined.
Yes, sir.
I get what it means or what it is, but like, how is that going to be?
What form will it be on the test? Can't really tell you that, except that I can.
Like, what is it? Like an ordered pair?
Yes. So if you saw something, not necessarily an ordered pair, but if you saw something that was like y equals, to use the example from the book, negative 4 divided by 0, x plus 3. Okay. What would that look like on a graph? What's our y-intercept? Okay. And so we go 1, 2, 3. Nope, we can't do it. Right? So it just doesn't work. Okay. Yep. If you saw it this way, let's go ahead and look at the example they have here is if you saw just simply this, if you just saw x equals 5, and you saw that on a graph, then you would just simply go to 5, and if x equals 5, then if you were to set this up as something that's linear, line, then, yep, it would just be a line. Whoop, that was supposed to go through there. Yep, so that, if you were to see this, the slope of that line, if you were to see something like that, and they said, what is the slope? Your answer would not be 0, undefined. All right, now page 55. Page 55 says, okay, forms of line. Notice I called your attention to this. Forms of line, it has y minus y1 equals m times the quantity of x minus x1. That's our point slope form. Then we have slope intercept form, y equals mx plus b. Then we have general linear form, which we call standard form. Okay, it shows you when to use those. Use the point slope form when you're finding equations of a line. Use slope intercept form when you're graphing lines. Use standard form when you're labeling your graph. And it doesn't say that in there, but that's the best thing to put on there, is to when you're labeling your graph. Any questions there? Okay, so I would guess a question that would come up is, why are you calling our attention to this? Well, because I want to make sure that you know when to use those. And since I'm pointing out all 3 of them, make sure you know how to use all 3 of them. For example, if you look at example number 5 on page 55, which I also asked you to write down, it says, find the slope of the lines that are parallel and perpendicular to the line that passes through, and then it gives you 2 ordered pairs. Okay, so you're going to see something very similar to that on the test. You're going to be given 2 ordered pairs and asked to find that line, or to find lines that are parallel to that line, or lines that are perpendicular to that line. They use first they found the slope, and so to find the slope, they, which is rise over run. They use rise over run. And you can see an example of that formula back on page 52. Example 2 on page 52. Find the equation of the line that passes through here. See that on page 52? Okay, so first they found the slope, and then they just did the m2 equals -1 divided by m1 to find the perpendicular. Okay. Did you have a question?
Yeah, can you do the
You bet. You bet. Okay, for skip, flip, and multiply, go ahead and jot down the time and skip, flip, and multiply if you would. So when we know that the slope of a line is, go ahead, you tell me a slope. Any slope you want. A number divided by another number. Okay, and I'm gonna do this one because most of the time we write it proper. Okay, we're just gonna pretend that's true for it. The first thing we'd want to do, if that were our slope, the first thing we want to do is reduce it, just because it makes it smaller. Yep, so we have 1 over 2. And you don't have to reduce it because it's going to be, they're equivalent, right? But the only benefit to reducing it is that you have really small graphs on your test, right? So it will help you with graphing if you count it over. So our slope of line 1 is 1 over 2. But if we wanted to find the perpendicular line, if it's perpendicular to this line, m1, then the way we solve that is we say -1 divided by 1/2. Or in other words, -1 divided by slope 1. With me so far? This is a complex fraction, and so to make it easier to work with, we're going to put -1 over 1. That is simply this number. And then we're going to skip this. We're going to flip this, and we're going to multiply. We skip this, we flip this. Yep, and to multiply with fractions, you just multiply straight across. So to multiply straight across, you have negative 2 over 1, which of course is equal to negative 2. Okay.
So this, if you start off with a fraction, you would set it to the whole number. You start off with a whole number, you would set it to the fraction.
Only if the fraction that you start with has a 1 on top. Because if you had, let's just do a second one. If you started off with a slope of 3 over 4, okay, then to find the perpendicular slope of the other line, it'd be 1 divided by 3 over 4. So we're going to skip the first one. We're going to flip the second one, and we're going to multiply. Then you have negative 4 over 3. That can be a slope. Because what that means is if our y-intercept, if we took a point and that we knew was our y-intercept, then we're going to go, which way with the 4? The 4 is our, which one? Do we go up or down? Or do we go right or left first?
Down.
Questioning. You want to look at it? Okay.
Down.
If this is our slope, okay,
Down
so
4.
very good. Rise over run. So that means that you go down 4, and then you go right 3. Okay? Good. Okay. Let's keep moving. The next thing I wanted to talk to you about was go to page 56. We're going to do a practice problem on page 56. Yes. A practice problem that I looked at and thought, oh, this looks similar to something they'll see on the exam. What I want you to do is take just a couple seconds, and I want you to try to determine, without me telling you a step, just pretending as if this were the exam, I want you to pretend that number 23 is on the exam and you're sitting there trying to figure out what to do with number 23. Number 23 says, the slope is 1 over 2 and the y-intercept is 0, 4. They want you to graph that line. I'm sorry, give the equation. They don't want you to graph it. They want you to give the equation of that line. So pretend like it's the exam. Take a second and write it down. What would the equation of that line look like? David? Correct. All right, this is what you would write on your test. How do you know that this is the form? Right, 0 is your x value, y is your y value, which is your slope. I'm sorry, which is your intercept, it's your b. This is your m, this is your b. So y equals 1/2 x plus 4. If it told you to write this in standard form, how would you write it in standard form? It'd be -1/2 x plus y equals 4. We don't really like to have a negative in front of the x, so we do what? Yeah, just change every sign in the equation. So then you have 1x minus y equals -4. Let's just change it all again.
Wouldn't that be the same as 1x minus y?
Minus. Say it again.
Y equals because
Oh, to get rid of the 1/2? Yeah. If you want to get rid of the 1/2 with it, you could do that too.
what if there was like the y instead of 0, 4, what if there was like 2, 4?
This one? If it were
No,
2y?
it'd have to be y.
Is that what you meant? Oh, this over here?
Yeah.
Then it wouldn't be a y-intercept. Good question. Yep, then it wouldn't be a y-intercept because the only reason this is our y-intercept is because x is 0. So when x is 0, on this line is 0, then y is 4.
Okay, thank you.
Good question. Okay. Now, as if it were the test, now do number 24. Because 24 on page 56 also looks similar to something you would see on your test. And this one, you will not just be able to write a formula, you're going to have to solve, and you're going to go back to page 55, forms of a line, and use the point slope form. It tells you on number 24 that the slope is -3, and it contains the point of 2 and 4. So that's very much what your question was, Austin. Okay, eyes up here real quickly. This is our point slope form. The question is, I put the 3 in already. How would I know the 3 should go there? Because the equation tells us it's a slope, exactly. Okay, so that's where that comes from. What points do I put in here and here? Here and here. Y minus 4, and here's the 4. That's where I'm getting the 4, and x minus 2, and I'm getting that from right here. And then what we're going to do is we're simply going to solve. So it's -3x plus 6 equals y minus 4. We can get rid of this 4 by adding it to the other side. And now we have y equals -3x plus 10. Questions? You're looking at me like I did something wrong, which I might have. Nope, I didn't. I did it right. Okay, so let me go a little slower. I took the 3 and used the distributive property. Excellent. 3 times x. 3 times -2. That would become -3x. A negative times a negative is positive, so that's +6. On this side, inverse operation. Add 4, add 4. Now we can graph it. What would the graph look like? Someone tell me, what is the y-intercept? 10. Okay, so up here we have 10. And then, what is our slope? It's written as a whole number. -3 over, no, very good. So this says that -3 over 1, m equals -3 over 1. Okay, so that means we come down 3 and over 1. And what's the last step before we leave this line? Label it. All right, so to label it, you would label it 3x minus y equals -10. And how did I get that? I just moved the x back to the other side and switched the sign so that it was in standard form. Good? Okay, we're almost done. So let's go ahead and give you another thing to look at. Page 61 and 62. Page 61 and 62. This is question number 3, if you'll write that down, David, and the time. For some more practice, page 61 and 62. This is all about graphing quadratic functions. Yeah.
We're gonna have to do the chapter 1.
Chapter 1. Trig? Sokotoa?
Yeah, something like that.
Sokotoa is not on there.
What about
Wait, I should say Sokotoa is not on there. I don't, Austin, I think Sokotoa is on there.
Yeah, that's fine.
Yep, SOHCAHTOA is on there.
Like,
I'm trying to remember the exam off the top of my head. What I have is I have the triangles.
like C sine, C over sine, C to the cosine, like stuff like
Law of sine, law of cosine.
Yeah.
Yes, law of sine is on there, law of cosine is on there. There's one question that shows you a triangle and it says find the 6 trigonometric ratios. There's another one that says, but I'll give you law of sine and law. But you'll have it in your notes. But I'll probably give it to you anyway on there. There's one that asks you, it says A equals this, little b equals this, C equals this. What kind of triangle is it? Remember that page of notes that we took? And I gave you a copy of a page, and it said, angle side angle. Yep.